All right, today we're going to do something fun. We're going to open up a time capsule and look at a piece of technology that started out in a top secret lab and somehow ended up on billions, and I mean billions of devices. We're going to unpack the incredible story of Java. And to do that, we first need to jump in our time machine and head back a couple of decades. So let me ask you a question just to set the scene. What were you up to in 1995? For some of you, you might not have even been born yet. But for the rest of us, technologically, it feels like a completely different planet, right? You see, to really get why Java was such a massive deal, we have to first remember what that world was actually like. I mean, just picture it, 1995. There's no Google, no Facebook, no Twitter, none of it. Most of us were running our computers on Windows 3.1. The web was, well, it was flat, just text and maybe a few pictures on these boring battleship gray backgrounds. And you got there by listening to that awful screeching sound of a 33K dial-up modem. Things we think of as ancient history now, like DVDs and USB drives, they were the hot new thing. This was the world that Java was about to turn completely upside down. Now, our story today is pieced together from what is basically a virtual junk drawer of old tech. Floppy disks, old conference badges, you name it. And it reminds me of this fantastic quote from one of Java's original engineers. He joked, "I'm really happy to be doing this presentation today because I can prove my wife wrong. There was a point to keeping all this crap." And he was absolutely right. That crap is our window into the past. Okay, so let's get into Java's secret origin story. Because here's the wild part. It was never, ever created for the web. Nope. It started out as this super clandestine project at Sun Microsystems that had a completely different mission. So it all kicks off in 1991. There's this off-site top-secret team called the Green Project. A small group led by James Gosling creates a brand new programming language they call Oak. Their big target? Interactive TV and smart consumer electronics. A year later, they have a working demo. The Star 7, this handheld device that was, honestly, straight out of science fiction for its time. But the market? It just wasn't ready. The whole project kind of stalls. But then, right at that moment, the internet starts to boom. And you have to appreciate the constraints they were under. That futuristic Star 7 device, it had a whopping 4 megabytes of RAM. That's it. To build an entire language and a virtual machine that could run smoothly in a space that tiny was just an incredible engineering feat. And it's one of the key reasons Java was so lean and efficient right from the get-go. And here's a fun little piece of trivia for you. Even Java's friendly mascot, Duke, comes from this era. He actually started life as this animated on-screen helper for the Star 7 device. They called him the Agent. For a hot second, his name was going to be Fang. Yeah, Fang. But the team decided that was maybe a little too aggressive, and so Duke, the icon we all know, was born. So the consumer electronics plan fizzles out. You could see that as a failure, right? But that setback led to what is, without a doubt, the single most important moment in Java's entire history, the pivot. They turned their focus to the web, and that one change of direction would end up redefining the internet itself. And the pivot worked because, almost by accident, their original mission had perfectly prepared Java for the internet. Remember, they built it to be secure, reliable, and network-aware for small devices. Well, what did the early, chaotic web desperately need? You guessed it. Security, reliability, and network awareness. It was a perfect fit. The new mission was suddenly crystal clear. Let's bring real interactive applications into the browser. The world got its first taste of this at the 1995 TED conference. And you have to put yourself in their shoes. Web pages were just static text and images. Then, all of a sudden, the audience is watching a 3D molecule that they can actually interact with and spin around, followed by an animated Duke tumbling across the screen. This wasn't a page anymore. It was a living application running right inside the browser. It just completely shattered everyone's idea of what was possible online. And the right people noticed. I'm talking about Mark Andreessen, the co-creator of Netscape Navigator, which was the browser back then. He was the golden boy of the tech world. He saw this demo and immediately gave Java this huge public endorsement. He decided Netscape was going to build Java right into their browser. And that was it. That was the moment. Almost overnight, Java went from being a cool experiment to being the language of the interactive web, destined for millions of desktops. So Java had pretty much conquered the browser, but its ambitions didn't stop there. The team realized that those same core features that made it great for small web applets, that security, reliability, and portability, were also the perfect solution for the huge complex world of big corporate server applications. So by 1998, they reorganized everything to go after all these different worlds at once. The core language became the Standard Edition, or J2SE. But then you also had J2EE, the Enterprise Edition, for the massive server-side stuff. You had J2ME, the Micro Edition, for early mobile phones and other small devices. And you even had Java Card, which put the power of Java onto tiny things like smart cards and SIMs. It was becoming a whole universe of technologies. And that expansion just kicked off 2 solid decades of nonstop evolution. The platform got bigger, the language itself got way more powerful, and to be honest, the whole ecosystem became a lot more complex. If you want one stat that shows this growth, just look at the standard library. In 1996, the first version of the Java Development Kit, the JDK, had about 211 core building blocks, or classes. By 2014, with JDK 8, that number had exploded to over 4,500. It went from being a handy toolbox to a giant industrial warehouse for developers. And the language itself kept getting more and more mature. We saw new graphics toolkits, better ways to handle big collections of data. Then came these huge leaps, like with JDK 5, which added features that helped programmers avoid common, painful bugs. And then JDK 8 introduced modern tools like Lambdas, which let developers write much cleaner, more powerful code. Every step was a major upgrade. Here's a fun, kind of nerdy way to see that explosion in complexity. In 2002, you could tune the Java virtual machine using about 159 different command line switches. By 2014, that number had quadrupled to nearly 630. Each one of those new options was another knob to turn, another way to fine-tune the engine, which just shows how incredibly powerful the underlying platform had become. Now, Java is absolutely legendary for its stability, for its promise to never break old code. But here's a great piece of trivia. It wasn't totally perfect. In its first 20 years, it broke that promise exactly 3 times. Just 3. It happened when they added new special keywords to the language. First, strict FP, then assert, and finally enum. If you're a programmer who just happened to use one of those words as a variable name, well, your old code would suddenly break. A very rare exception to a very important rule. All of which brings us to Java's legacy. I mean, after all this time, why is it still one of the most dominant programming languages in the entire world? The answer really lies in that foundational rule we just talked about. So what's the magic number for Java's legendary stability? It's 0. For its first 2 decades, the Java team could mark a feature as deprecated, which is basically a polite warning to stop using it. But the number of those features that were ever actually removed from the platform was 0. Not a single one. That unwavering, rock-solid commitment to stability meant businesses could bet their entire companies on Java and not have to worry that a future update would destroy their investment. It all came down to that core philosophy, that famous slogan, write once, run anywhere. The Java Virtual Machine, the JVM, acted like a universal translator. You could write and compile your code on a Sun workstation, and that same exact file would just run, no changes needed, on a Windows PC, on a Mac, on a Linux server. In fact, code compiled back in 1996 can still run on a modern JVM today. That's the real magic of its stability. So when you boil it all down, Java was simply the right language at the right time. It was perfectly built to solve the biggest problem of its era, taming the static, chaotic early internet and making the dynamic web possible. Which leaves us with a final thought. If Java was built for that world, what are the huge, complex challenges we're facing today? And what will the next great programming language be built for? That's our explainer for today. Thanks for joining me.